Welcome back to another video, and in this video we're going to be continuing on with our SwiftUI tutorial series, and in this particular tutorial we are going to be taking a look at table and table column in SwiftUI. Now, when we think about a table, of course we think of rows and columns of data, right? Some people will describe a table as a multi-column list, which is exactly what a table pretty much is. And in SwiftUI, tables take on a different appearance based on the platform. So on macOS, if you have taken a look at Finder or any other application that uses a multi-column kind of tabular display of data, that is what a table with table columns will look like on macOS. However, on iOS and iPadOS, table behaves differently. So on iOS with iPhone, you will only be able to see one column of data, and that's it. And that's because of the width restrictions on iPhone. You can't embed a table in a scroll view and then have it scroll so you can see more columns. That's just not how it's designed. On iPad, though, you can see more than one column of data in your table. Now, of course, on iPad, it'll look slightly different than the table on macOS does, and we'll take a look at that. So let's go ahead and go into Xcode and talk about what it is that we're going to need for the most basic kind of table. All right. So the first thing that you're going to need is some kind of array or set of data, some kind of collection of data. Preferably an array, because that is a little bit easier to work with. But if you have, for example, stuff from core data that you want to display in a table, that will work as well. Now, what I have here is I have a state variable called movies. Now, this stores a bunch of movie objects from my constants file, and I have them sorted by title. Now, movie is a struct that conforms to identifiable, and it has a couple properties. First, it has an ID property. Second, it has a title, so the title of the movie. It has the director, so who directed the movie, and then an integer for the release year. The ID is a UUID. As I mentioned, the release year is an integer, but everything else is a string. And that will be important here in a moment, because when you need to display integer data compared to string data in a table column, you kind of have to do it a little bit differently. All right, so let's go ahead and go into our body. And the first thing that we want to do is we want to create our table. We can do this by saying capital T table, and then passing it the data that we want to display. So it'll be, in my case, movies, and then open it up. Now, this closure here takes in table columns. Not views, but table columns. So we can say, well, let me double check. Okay, yeah, we're good on the font size. We can say capital T table, capital C column. And the first thing that we want to pass in is we want to pass in the column header title. And then it's the second one, because this is going to be a string that we want to display. We just need to pass in a key path to that value. So we'll say movie title The second parameter has a argument label value, and that'll be backslash dot title. Okay. Table column with a title of movie title, comma, value. So this will be backslash dot title. And this will go ahead and grab the title of every movie in the collection as it goes through the different cells in this particular column. Next is the director. It's the same process because this is also a string. Capital T table, capital C column. First, we need the first parameter, like the first column, is to pass in the title for the column. So we'll say director. The second is value backslash dot director. Now, remember how I said that integers are a little bit different in terms of how you handle that compared to strings? This is kind of what I mean. So for a integer value, we need to provide a view hierarchy for the cell instead of using a key path. And we can do this by saying table column, give it the title for the column. In this case, it'll be release year. Then we pass it a content closure. And this content closure actually takes in a parameter, and this parameter is the current movie being iterated over, or if you have, or whatever data model you're using. So if it's a book or a genre or anything else, really, whatever it is that your data model is, you'll get an instance in this content closure. So I'll say movie in. Now inside of this closure, we can put any view hierarchy we want, but I'm just going to have text in here because we just want simple text. It'll be text string movie dot release year, like that. All right, so let's go ahead and save that and run our code again. Well, we'll run it for the first time in the video, I guess, but let's see, I did not change my run destination. So let's do that. So let's take a look at what this will look like on the iPhone first, just so you can get an idea. Because Table does work on iPhone and iPad now. It didn't originally. When the table view in SwiftUI originally came out, it only worked on macOS. It was only, I think it was a year later that they made it work on the other platforms. So here is Table on iOS. Right. So you can see we have a bunch of rows. We can scroll through those rows, but we can't scroll through the columns. It'll only display one column on iPhone. Right. We can rotate the phone, and it'll still show one column on iPhone. Okay, so that's what it looks like on iPhone. What about on iPad? Well, let's take a look at iPad Pro 13-inch, largest iPad there is. Well, other than the 13-inch iPad Air, but you get the idea. So here's the iPad, or at least it should show up. Okay, so here we go. Okay, it's not cooperating. Let's try running that again. Okay. Okay. So this is the table on iPad. Let's go ahead and run this on the Mac here. My Mac, run. Alrighty, here we go. Now here is the app on macOS. So you can see our movies are being displayed in a table. We have 3 columns. We have the movie title, we have the director, and the release year. So because we have our movies sorted by title in descending order, we have the W's first. So the first one is Wreck-It Ralph. Rich Moore is the director. And then 2012, it was the release year. And we have, it just goes on and on. Now, these are just a random, this is just a random list of movies. I chose a bunch of random movies from sites across the internet. So there's nothing in particular in terms of like, oh, what kind of genre of movies did you choose specifically or anything like that. I just chose a bunch of random movies from a bunch of random sites, and this was the result, right? So we got all kinds of movies. We got Up, we got Toy Story, we got Silence of the Lambs, we've got The Godfather, we've got, we got all kinds. And they're from all different eras. That's one criteria I had. I wanted to make the release years kind of, vary. Like, I wanted to have a variety of release years, not just those released in the 2000s or the 2020s or the 2010s or something like that. I wanted it to span across multiple decades to kind of get my point across. So that's how we can display data in a very basic table. But there are some things that we can do with a table that you might find useful. The first thing is we can support selecting items in a table. So let's take a look at how we can do that. Inside of Xcode, the first thing that we're going to need is a state variable that can hold the selected item or items. So a table allows us to select one or more rows. However, the way we would select multiple rows is different from being able to select one row. If we want to select one row, we need to hold an optional object of the identifier for our data model. All right, so if we go into Xcode and go into our view here, above our body, we can say @state private var selection colon movie dot ID. Now, this ID property can only come from an object that conforms to identifiable, and this is a UUID. So it will be the ID property of our movie that gets assigned to this variable. Now, we have to make sure that this is optional, like that, with a question mark. Now, supporting that selection, it's as simple as adding an argument to the initializer for our table. So we'll say comma selection. This takes in a binding to a UUID. We'll say $selection, like that. Save it, run it. All right, so here is our table. And you can see now we can select any row that we want. And it is highlighted to indicate which row is selected. Pretty neat stuff this far. Now I'm going to change the sort order here. So now it'll be in ascending order by title. So if you wanted to support multiple selections, instead of having an optional ID for your data model, we can surround this with angle brackets and make this a set. So it can be a set of movie.id in this case, because we want to be able to, select multiple items, and a set is perfect for that. The reason why we're using a set instead of an array is because that's what multiple selection for tables requires. But I assume that the reason Apple chose to use a set instead of an array for this is because of performance. Though if you have too many rows in a table in SwiftUI, it will start to slow down. So you have to be a little bit careful about how many rows you have. If you have a massive amount of rows and you find that your application is slowing down, then you might want to consider reaching down to AppKit to use NS table view instead, which does the same thing. It's just that's macOS specific, right? So we will cover how you can do something like that in a later video in the series, but for now we're not going to worry about it. All right, so now that we've simply changed the type, our table supports multiple selection already. So let's run our app again. Or at least it should. Okay, so movie.id, put that in the angle brackets, and we'll set it to an empty set for now. Save it, run it. Okay, we have a successful build here. And so now you can see we have a bunch of movies listed again, but this time they are in ascending order. We can select them all, and you can see it does select all of those rows. All right. So we have 12 rows selected now. So if you wanted to, you could delete all of these objects based on the selection and all that stuff. You would just have to make sure that you can delete them by their IDs rather than like looping through them and deleting them. Okay, so that is how we can support selections in a table. The last thing I want to show you is how we can support sorting our data by clicking on the column headers in our table. Now, because VoiceOver doesn't allow me to focus on those column headers, I'm not going to be able to effectively demonstrate it. But when we implement what we're going to implement here, we can click on those column headers if you can use a mouse to be able to sort them. All right. So first thing that we're going to need to do that is we're going to need an array of key comparator objects. So we'll say @state private var sort order colon key path comparator equals, and we'll open up the array here. Now inside of this array we'll have some key path comparator objects. You can have one or more depending on what columns you want to be able to support sorting on. We're going to use only the title and the release year. So you can sort them in that way. We'll say key path comparator and then we'll have the one where we'll have the version of key path comparator that we pass in the key path and the sort order. So it'll be /movie dot title and then we'll say the order is going to be dot forward. We'll have a second key path comparator object, key path comparator /movie dot release year, comma order of dot forward. Now you could say, oh, we want the release year to be dot reverse, which will be in reverse order rather than going from earliest to latest, right? So that is our sort order array. The last things that we need to do is we need to add the sort order binding to the table. And then we need to add a key path to our release year column, because when we are able to support sorting in our tables, then it is required the value parameters required to make sure that the table can properly sort everything. And if you try to add a value parameter to a column with a view hierarchy in a content closure when you don't support sorting, Xcode will yell at you saying, hey, you can't do that here. All right. So after our selection, we'll have sort order. We'll say $ sort order, like that. Now let's go down to our third column. We'll say value is \.release year. Just like that. We'll save it and run it. We have a successful build. And here is our table. All right. So there we go. You can see now that we have our table. It works fine. We can select multiple rows. If you click on the table columns for the title and the release year, they will sort accordingly if and only if we have a onChange modifier where we manually sort our array using our sort order array that we have. So what we'll do is on our table, we'll say dot onChange of, it'll be sort order. We will say movies dot sort using sort order. So every time the sort order binding changes, we will resort the array in place. If we save it and run it now, it will work. And so there we go. All right, so with that pretty much does it for this video on how we can use tables and table columns in SwiftUI. Thank you all so very much for watching, and we'll see you in the next video.